Good morning to all of you. So I am Dr. Alok Agrawal and I am here to take your next lecture on course Internal Combustion Engine having subject code ME501. So today's topic is very important topic and it has been asked in exam most of the time. So today's topic is on firing order. Okay, so let's start with what is firing order? So firing order is the order of sparking in the cylinder of a multi-cylinder engine. So first of all, we have to keep in mind that it is for multi-cylinder engine only, not for single cylinder engine. And firing order is in which order we are sparking the cylinder of a multi-cylinder engine. Okay. Actually, in an ignition system, the distributor passes the spark to each spark plug. There is a distributor which supplies spark to the spark plug that leads one at a time, and that thing occur at one at a time. If there are four cylinders, only one cylinder can be sparked once at a time. Okay, so we can say that in one revolution, when the crank completed its one revolution, number of spark produced is equal to the number of cylinders. So when it is actually connected, the distributor is connected to the crank, and when distributor has completed one complete 360 degree of revolution, it will its work is to spark each and every cylinder. So the number of sparking is equal to the number of cylinder. Okay. So from this statement, ignition system will be like that, where the distributor passes the spark to the spark plug, and the number of spark depend upon the number of cylinder, because it has to get it has duty to spark each and every cylinder in one complete revolution. Okay. So, if we consider a four-stroke four-cylinder engine, that then this in two complete revolution, because sparking occur in four-stroke engine, sparking occur when crankshaft rotate twice. One sparking is required at the time of compression when the compression stroke is about to end. One sparking is required in two revolution of crankshaft in case of four-cylinder engine. So if you are talking about four-stroke engine, four-stroke four-cylinder engine, then it has to be sparked when crank revolution completed two revolution. That is 720 degree of crankshaft revolution. Okay. So how many will be the number of sparking? There will be four sparking because number of cylinder is four. So when we divide 720 by 4, we will get 180 degrees. So it will be like that sparking has to take place in every 180 degree of crankshaft revolution. Okay, it is like that. Now the order in which the cylinder is sparked means first, second, third, fourth, or whatever will be the order, it is called firing order. Now, the firing order of an engine depends upon the number of cylinder in the engine. It has been seen that number of sparking is equal to the number of cylinder, but also the firing order depend upon the number of cylinder. Okay, there will be different firing order for four-cylinder engine. There will be different firing order for three-cylinder engine, and there will be different firing order for 6, 8, or 12-cylinder engine. Okay. The power stroke also need to be equally placed to get an equal balanced movement of the crankshaft, because we are dealing with the engine will move and it will have a lot of moving component. So the power stroke also has to be balanced accordingly. Okay, so that there will be a balanced force in the crankshaft and the crankshaft will not get any particular load at a time. Now, what are the various factors which decide the firing order? So there are mainly three factors which decide the firing order of an engine, whether it will be a three-stroke engine or four-stroke engine or 6, 8, 12. The main three factors decide the firing order of an engine. So first is engine vibration, second one is engine cooling, and the third one is development of brake pressure. So we will see each one of them one by one. So first of all, let's start with engine vibration. So I am considering here four-stroke four-cylinder engine. So here 1, 2, 3, 4 are the four cylinder of the engine. Okay. Now I am considering that the first sparking took place at cylinder number 1. So when the sparking took place, what will happen? The fuel will burn. The fuel will burn and it produce a large amount of energy. And because of that large amount of energy, that energy forces the piston in the downward direction. So suppose this F is the force imparted by the burn gas on the piston head. Okay. So when there will be a force in the piston head, piston will start moving downward, and this force will be taken by the two bearings or two support of the crankshaft. This red one is crankshaft. Okay. Now see how the force will be distributed. It is just a simply supported beam problem. If there will be a force F which is at a distance of A from bearing A and at the distance of B from bearing B, then by applying the formula of simply supported beam, we get the reactive force at bearing A will be F into B upon A plus B, and the reactive force at bearing B will be F into A upon A plus B. So which force is large? Obviously this one, because B is greater than A. So in this bearing there will be a large force. Fa will be greater than Fb. Okay. So clearly the force on the bearing A is more than the force on the bearing B. So if we'll fire cylinder number 2 after cylinder number 1, then what will happen? Again the A will change, the B will change, but again the B will be greater than A. Okay. The distance between 2 and A will be lesser as compared to the distance between 2 and B. So if we will fire second engine after engine 1, then what will happen? The load in the bearing A will increase again, which causes the vibration, engine vibration, because twice in a cycle the load is more at point A and B has yet not having much load, so there will be engine vibration. So to reduce this vibration, we will not fire engine 2 after engine 1, we will fire either 3 or either 4. Okay, so that has to be optimized depending upon the other parameter, that is engine cooling and back pressure generation. Okay, so it has been clear from this discussion that we cannot fire cylinder 2 after cylinder 1 because it causes engine vibration, as the load in the bearing A will be more at a particular time and there will not be any load in bearing 2 as compared to bearing 1. So the second factor is engine cooling. Again, when the first cylinder is fired, its temperature will increase. Obviously, when the energy will be produced, its temperature will be increased. If we will fire the second cylinder after that, what will happen? The temperature of the second engine will increase. So the engine, the part of the engine in between cylinder 1 and cylinder 2, what will happen? It will get overheated. And at the same time, cylinder 3 and cylinder 4, it has not encountered any kind of firing, so it will be relatively very cool. So at one part of the engine, it get overheated, and other part of the engine, it does not have any heat. Okay, so what will happen? The task of the cooling system will be difficult, because at the same time it has to give cooling at one part of the engine more as compared to the other part of the engine, because one part of the engine is getting overheated and another part is not. So it will be very difficult task for a cooling system to change its position with respect to time. Means first to sparking, the cooling will be more effective at near 1 and 2, and in another part it will be more effective in 3 and 4. So if we fire third cylinder after first cylinder, then the problem of overheating can be reduced. Okay, so because of engine cooling also, we cannot fire directly second cylinder after first. Okay, now the development of back pressure. Again, what will happen after firing the first cylinder? What will happen? The exhaust gases which are getting created will come into exhaust pipe, and if we fire the next cylinder 2, then what will happen? We will find that before the exhaust gases coming out from first cylinder goes to the exhaust pipe, the gases exhausted from the second cylinder started to overtook them, and because of that, what will happen? There will be less space in the exhaust pipe, and the gases coming out from cylinder 1 and cylinder 2 will be more. So to solve this problem, what we have to do? We have to increase the size of the exhaust pipe. And if we increase the size of this exhaust pipe, the overall dimension of the engine will increase. Okay. And if we will not do this, if we will not increase the size of the exhaust pipe, what will happen? It back pressure will be created, and it will increase very drastically. So to solve this problem, either we have to increase the pressure of the size of the exhaust pipe, or we can do one thing, that instead of firing cylinder 2, we can fire cylinder 4, so that till the time exhaust gas of cylinder 1 will come out of the exhaust pipe, 4 will come, and from other side second cylinder exhaust gas will come. So instead of firing cylinder number 2, number 4 cylinder can be fired by the time exhaust gas of cylinder 4 come into the exhaust pipe. The gas from cylinder will have sufficient time. Okay, and it will have sufficient time to travel the distance between 1 and 4, and because of this the development of high back pressure can be avoided. So from this all these three parameters what we have seen that definitely after the firing cylinder 1 it should not be cylinder 2 which will be fired. So it can be either 3 or can be either 4 depending upon the doing optimization, doing a number of runs, and considering these three parameters to get its minimum value, means engine vibration will be minimum, engine requirement of engine cooling will be minimum, and development of back pressure will be minimum. There has been come out that for four-cylinder engine, the best firing order is 1342 or 1432. Either can be used. Whereas for six-cylinder engine, it can be 153624. And in case of eight-cylinder engine, it can be 15426378. So all this data is from the experimental analysis of on the basis of those three factors. Okay, so this firing order is very important because it governs the comfort and it governs the life of the engine. So it will be like this. This is the animation that I have shown of firing order. Here it can be seen that after cylinder 1, 3 will be fired, 4 will be fired, then 2 will be fired. Okay, you can also see cylinder 1, now 3, 4, 2. 1, 3, 4, 2. So the firing will be occur like this only in actual engine as well. Okay, so this is all about the firing order. Thank you very much. In next class, we will study on about Morse test. Okay. Thank you very much.